Good morning to all. I am Subramaniam from SNS College of Technology, working as an assistant professor in automobile department. In this session, we are going to see about the casting of the piston using the gravity casting. So, gravity casting, also known as gravity die casting or permanent mold casting, is a widely used method for the manufacturing of the piston. This process involves the pouring of metal into a mold under the influence of the gravity without the use of any additional forces. And first we see about the metal selection. Pistons are typically made up from the aluminum alloys due to their excellent properties such as lightweight, high thermal conductivity, and good strength to weight ratio. Common alloys used include A35, A356, 4032, and 2618, which offer a good balance of strength, ductility, and wear resistance. All these grades are given as A356, 4032, and 2618 are the aluminum alloys. And next comes the mold preparation. The molds used in gravity castings are usually made from steel or iron and can be reused multiple times. The mold consists of two halves, a core and a cavity that together form the shape of a piston. Prior to the casting, the mold is preheated to a specific temperature to ensure the uniform metal flow and reduce the thermal shock. A mold release agent or coating is also applied to facilitate easy removal of the cast pattern and enhance the surface finish. Next comes the melting and pouring. Aluminum alloy is melted in a furnace and brought to the desired pouring temperature, typically about 700 degrees centigrade to 750 degrees centigrade. The molten metal is then carefully poured into the mold through a gating system. The design of the gating system is crucial as it controls the flow of the metal and minimizes the turbulence, which can cause defects like porosity or inclusions. And next is solidification cooling. As the molten metal fills the mold, it begins to cool and solidify. The cooling rate is controlled to achieve the desired microstructural and mechanical properties in the piston. Solidification starts from the walls of the mold and progresses towards the center. Controlled cooling helps in minimizing the internal stresses and ensuring the uniform properties throughout the piston. Mold operating and ejection. Once the metal has been completely solidified, the mold is expanded and the piston is ejected. The mold design typically includes the ejector points to aid in the removal of the solidified piston without causing any damage to it. Next comes the heat treatment. The enhanced mechanical properties of the cast iron heat treatment process, such as solution heat treatment and aging, are performed. Solution heat treatment involves heating the piston to a high temperature to dissolve alloying elements, followed by a rapid quenching. Aging is then done at a lower temperature to precipitate the dissolved elements, thereby increasing the strength and hardness of the piston. And next is the machining process. After heat treatment, the cast piston undergoes various machining operations to achieve the required dimensions, surface finish, and features. This includes the turning, milling, drilling, and grinding. Critical areas such as piston skirt, running grooves, and pinhole bores are machined to the tight tolerance to ensure the proper fit of the and function of the engine. And next comes the inspection and quality control. Throughout the casting, the machine process, the rigorous inspection is and quality control measures are implemented. Non-destructive testing methods such as X-ray inspection and ultrasonic testing are used to detect the internal defects. Diagnostics are preferred using the precision measuring instruments to ensure all specifications are met there. And the surface heat treatment. And with this, we come to the end of this session. Thank you for watching it.